Okay. So hello and welcome back. Oh, I'm just tired, man. I'm tired. I'm tired. Let's keep going. I think we talked about this problem yesterday. I didn't work today. I was working on something that took some time, so I didn't really have downtime to work on this. Yeah, actually, I thought the thing that I was working on, I thought it wasn't going to take me that much time, but I ran into some bugs. I think it's actually finished, almost. Just a couple more details to wrap it up. Anyway, oh, freaking exhausted, man. Has nothing to do with my anything. Just I just stayed up kind of late last night. I don't know. I get distracted sometimes. Get kind of excited and just can't sleep. Oh man. Sheesh. My head. Head, my heart, my soul. I don't know. Yeah, we'll keep working here. Keep working on this. I think I've made a decision. I was going to not sort of live out the rest of my days in New York. I thought that was something I wanted to do. I thought I wanted to leave, move. But the more I thought about it, the more it's like, if you're called by God to spread the word, the gospel, then New York is pretty much an what's the word? Not untouched, but unheard. Excuse me. I don't know what the expression is for that, but they need to hear the word in New York. So, I should stay. Stay and preach. Linger yet a while longer. And man, I've got this, I guess you call it crippling depression. I don't know if I'm just tired, if that's what it is. I shouldn't really have that. I shouldn't be that tired. I'm not tired. I shouldn't be that sad. Like I said, I'm not so sure all the decisions that I made were wrong. And what is it I'm so upset about after all? Some of the decisions were obviously wrong, but the thing is, you can't go back and change what you did. You can't change time. And there's loads of opportunity for me. I mean, more opportunity than I can even grasp in my mind. So, yeah, I mean, I just gotta kind of keep the word of God and keep, how do you express that? Excuse me, keep the word of God and keep my, keep the faith, keep hope for myself, and then keep my love of God. When I die, I'll go to heaven, and in between, maybe enjoy my life. Possibly, hopefully, I don't know. Yeah, worn out. It's not even that I'm worn out, I'm just tired because I didn't sleep enough last night. That's it. That's really it. Everything else is fine. Otherwise, everything's fine. Alright, we got about less than 40 problems left, right? Yeah, so just slowly grind it out here. Okay. So I went over the solution for this yesterday. Just a simple depth first search, and we're not going to do anything fancy where we sort of prune the next steps, the next iterations. We're just going to dump everything into a set and just iterate over the set. So let's start with getting a name for this function here. Okay, let's call it maze. And excuse me. Could even call it 4Science, right? We'll do that, and let's go get ourselves the test cases, one by one here. Alright. 1, 2, 3, 4, 5, 6, 7. And we'll add to each. 1, 2. Okay, well, that's fine. We get multiple lines. 3, 4, 5, 6, 7. We're going to add print line to each of these. Let's do that. And okay, so now we want science. Let's do that. And have a few different things we're going to do. So the use the let to write some subfunctions. I do agree. I think a friend of mine mentioned that learning functional programming makes you a better programmer, and I would tend to agree with him on that one. Because I've noticed in my programming at my job, what I've been doing, I've sort of improved. My approach is quite different now. Anyway, what are we doing here? We want to what are we doing? Try not to fall asleep here. Excuse me. Do an inbounds check. So we can do n row and column. And row is going to be the count of x. then end column is if end row is greater than 0, or if it's 0, or yeah. Actually, even better. If empty of x, then return 0, otherwise count of first of x. Alright, that gives you rows and columns. I'm going to say inbounds. Function row column. And this is every is true of the following. Row is greater than or equal to 0. Column is greater than or equal to 0. Row is less than n number of rows. Column is less than number of columns. Inbounds. Another routine is going to be directions given some row column. This will be a for loop over ij. Actually, it's just to be a simple sequence of cons. I'll do it this way. Use a vector, it's simpler. Row -1. Let's do vector vectors. Row -1 column. Row +1. I could just do decrement row, decrement column. Increment row. Man, I saw something the other day that didn't really upset me. It's just, it didn't upset me that much, but did upset me when I thought about it. It's a woman, very attractive, online. I probably should focus on what I'm doing here though. Yeah, never mind. Just focus on what I'm doing. Talk about that another time. It's not really even worth talking about. It's just, there's a lot of wicked people in the world. That's it. So now what we want to say is generate adjacency map. Whoops. Oh, I see. There we go. Nice. So 1, 2, 3, 4. And then this is 1 less, 0, 1. Yeah. Cool. So that worked. Alright, now we can build this adjacency map. It's basically just a reduction over the open spaces. Use a reduction. Come back to that shortly. Now we want a hash map. And we want to hash over the open spaces. What we're going to do is, we've got what we're going to return. Got a new tuple. And this will be rather simple. We also want something else too. Something else I want. We want M and C. I want to find those two spaces as well. Do this all in one shot. So we're going to take 3 things. M and C. Where the mouse is and where the cheese is. What we're going to do is say, given V, I get directions of, so first let's destructure V into row column. And let's get the directions of row column. And let's say, let's filter on, no, we can say, let's use a let also. something we want to do here. So we want to get the directions to the row and column, and then we want to filter over those directions for only, and we'll say next spots. Filter using, we want to say that for both inbounds, the directions, and inbounds of row column, or just no. Destructure this as well. Inbounds and this guy. Contains one of these three things. Inbounds is open space. Yeah. Sure. That works. Also, you can just do this. So you've got your next spots, and then we're going to say could use an if ret contains row column as a tuple. I don't think it even matters. I think we can just M is going to be if nth of board the row column this is equal to M say M is row column, otherwise we'll leave it as M. We want to find the mouse and the cheese starting points. MC. And we just say associate ret with key row column, and we're going to place the set, or the vector, just vector of next spots. Vector sequence doesn't matter, whatever it is. Yeah, and then MC, and return that at each iteration. Okay. What do we end up with here? Let's see if this even functions. Excuse me. Oh, of course. I miss that sometimes. Ah. Excuse me. Cool. Pretty neat. Pretty neat. Neato. And now we'll just do a BFS reduction. We could do another, it'll really just be an iterate, I think. And I think I talked about this already, how to do this. So we're going to perform an iteration where we're going to iterate over the, so we can let map or adjacency map MNC be this call to board, and then we can iterate here over starting from M, right, row column M, and apply this BFS iterate. And actually, you're going to start with two things. A vector with this in it, set, and an empty set. And the idea is, you could do both of these. You're going to take this set and move it here. We want to sorry, the other way around. We want to consider these two to be the previous iteration and the current iteration. And what BFS iterate is going to do is we're going to use a take while. Let's see how that works. But what we want is they're not equal initially. One is empty, one has got the initial starting point. And what you do is you move what's here to this position, and then what's here you operate on. Right? So I'll show you the take while a bit later. This will be interesting. Destructure to previous current. Let's return nil for now. And you're going to take while or drop while. That's really what you want. Actually, you want to iterate until you want to take while. Take while they're not equal, the sets, or you don't have C in the set, and then you're going to return the second of these, and you're going to say contains C, and that's all you need. And you're going to say iterate BFS iterate will be, we'll get to that shortly. So actually, I can also do take while predicate, throw this in here. And then we can also use a threading macro. This ended up being a lot more involved than I thought it would be. I don't think this is going to be this difficult, or just this much time, I guess. There's different pieces. All right, BFS iterate will say we're going to take previous current, and we're going to return two things. This will be the current, and this is going to be a into current of the way this is going to work is it's actually the other way around. You're going to map. No. I mean, you could do a reduction too. Yeah. So reduce into current here over each value in current initially. I don't know if this will work. No, this is what do they call that? Maybe not. Let's do it this way. Map cat of this adjacency map. Shucks. The adjacency map will be in lexical scope. I guess we could do it this way. Keep it in scope. Apply the adjacency map to map this value to what's in current already. And this is going to take this function will be, it's effectively the adjacency map. Yeah, you just apply it. Right. I'll push into, yeah, okay. And then we say, if previous equals current, then we return false. Actually, this is just a predicate, so if they gotta be not equal, if they're ever equal, then we're done. They're not equal, or current contains C. So keep taking while either these aren't equal or you don't see C in there. Actually, it's got to be an and. So keep taking if they're not equal and you don't see C. If you do see C, then you're done. Or if you see Yeah, this is negated. Let's keep taking. And then finally they're either equal, which you take the second, check if C is in there, return false. If they're not equal, take the second, that means you found C, check if C is in there. And that's it. That ought to do the trick. We'll find out now if this functions at all. It's a lot of code to write without any interruptions or any checking. See if I made any compile errors. Oh, or any mistakes. Look at that. I got false for this one. There's a function you can throw in here called log. Very useful. Let's see what happened. What happened here? Oh. These two sets, huh? Interesting. Zero, zero, 0001. Now that doesn't make a lot of sense. Let's take 5 of these and let's log this. Very interesting. So 676757. Let's actually go to the first case, right? So here we have 04. Fair enough. Now we say, excuse me. After 5 iterations, we end up with, and we took 5. Now this doesn't seem correct, right? And we can print M as well, right? Should just be 00, 0. Yeah, I think they're all 00, 0 initially. Okay, 0400. Fair enough. Let me throw code on. I'm freezing. Holy smokes. Okay. Kind of expect this. This is somewhat expected. I've got this BFS iterate, take 5 log. Now here's the part I'm confused about, right? Like, isn't this supposed to be a sequence of 5 things? Maybe the point is that this doesn't go 5 things out. It just goes 0, 0, 0, 1, and that's it. I need to go put a code on. Excuse me. Oh, look at that. Now this works okay, but somehow this doesn't work. What is going on? Why, this doesn't seem to work correctly, this threading macro. That don't make no sense. That don't make no sense at all. What? This. Excuse me. Oh. Oh. Got it. I think I understand now. I just misunderstood. It is working. It's just not so obvious what's happening. Okay. This is logged. Wrong one. This one, yeah, this is logged. And the second of these is this guy. Okay, got it. Okay. So actually what you need is just the first of this sequence. No. You take while this is true. And you want the last of these, actually. It's confusing. No, it's not the last of these. It's... I think you want drop while. And then take the first. And then take the second of that first. I think that's what we want. I think that makes a little more sense to me. Yeah, okay. There we go. That's what we want. Just gonna go ahead and test. So this is the C, is the target that we're looking looking for here? Oh boy. Okay. Zero 4. It's right there. You've got to be kidding me. You must be joking. Is that a joke? It's right there. It's there. It's in there. It's actually in there. It is definitely in there. Oh, I need to go lay down. Oh, my brain's starting to mush. What? Excuse me. This doesn't make any sense. I think this should be an or. By the way, you're going to drop it if these aren't equal. I don't know. I had the right idea, I think. This is super confusing though. Oh, duh. Oh my goodness. Oh, you gotta be kidding me. Oh wow. I'm really just okay. That's why. Right. Yeah, you know. This is great. Alright, so this is true. Got him. Now the next question is, why do we get 0, 0, and 0, 1? Or 3, 5, and 0? What happened? Oh, we said take 5, that's why. Get rid of that. Get that out of there. Scoot. Everything's true. Awesome. I'm the best. I'm the best there ever was. One more time. Uno más. Hey. Oh my goodness. I need to go use the bathroom. I'll be back. Dude, that was ridiculous. That took so much effort for no good reason. Come on, man. Had the right idea, just I don't know, man. 50 lines of code later about that. Just simple BFS just takes forever. Dude, that took an hour. I don't know what to think, what to make of this. Kind of want to look at the solutions. I should go use the bathroom. I should do that. Yeah, maze. Directions. Map, partial map, plus. Could have maybe done that. That may have been better than what I did. Which was, yeah, increment. Yeah, I should have used that. A summation over this. That would have been so much better. Entry. Row, collection, when, get in maze, row. I don't know what that is. Oh, looking for the entry point. Yeah, I did that also in one shot. I found my entry point here using my reduction. PS entry visited, set entry, difference. Yeah, they just went set by set, or visited. Increase this visited set. My code took almost 4 times as many lines of code. Although I did use a lot more. Yeah, I mean my code is a lot more space. Just has a lot more space. Just how I write it to make it kind of concise, make it clear. Science. Jesse Pinkman, man. Not impressed. Potty mouths do not make it to heaven. Adam. What are you using atoms for, man? Don't need atoms unless you're doing something, I guess it's concurrent. Even things that are concurrent, you really don't need atoms. You just need weights put in the right spot. I'm not the only one who had like a few different routines going on here. I think I could have made this a little bit better. Oh, I did that wrong too. Let's drop while predicate. I like mine, man. I'm just gonna say I like it. Go with that. I'm just going to say that I like mine. Go with that. Yeah, I'll be back. You can enjoy nice graphic while I'm gone. Oh. No. I'll be back. I'll be back. Alright, so we're back. Forgot that I had my camera on here the whole time. Kind of ruins the facade a bit. Anyway. Yeah, it seems like these are not super popular. Audio bitrate is 0. Nice. Interesting. Okay. Right, so let's go to the next problem. Yeah, the other solutions are interesting too. AGET, what does that do? What is that? Array index. Oh, okay, we should do AGET. Yeah. Yeah, it's probably better. Yeah, I should use that AGET. It's better. There's some value in just looking at these things. Just kind of poking around with them. But I like my solution overall better. What does this do at B? Oh, it's an atom, that's why. Referencing the atom. Re-implement map. Interesting. Kind of wondered how map worked. It's one of these higher order functions that we've got going on here. It's actually not a higher order function. It's just a useful function. Useful built-in. So, what do we do when we map? We map cat4 map indexed. But how do we operate over? I guess we could just use a recursive sequence, like a lazy sequence here. It's a lazy sequence. Yeah. So we'll say, okay, we can do this. No problem. No problemo. Let's grab each of these. Wait, what did I do? Oh, got it. Whoa. I mean, okay. Anyway, so we're gonna say map2, I think is what I was using before. New map, test map, whatever you want to call it. So this map, we've got a few different pieces, right? Got a sequence, call it collection, and you got a predicate. You're gonna return a sequence. Oh my neck, man. COLL for collection. So what we do is we have a lazy sequence. And we're going to take cons of map 2. And what we're going to do is, or just not predicate, function. And we're going to, no. Cons f of collection. Now it's not going to be collection. Do a loop. Yeah, okay. Let's do it this way. Okay, this is a little bit easier. So maybe it's not as difficult as I thought. Maybe one thing we need here. Just need a terminating condition here. Base case. Oh. 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 Okay. Let's see what we do. Nice. Not bad. Nice. Yeah, I think that's pretty good. We'll just move on. Well, actually, I kind of like to look at the solutions just for the sake of it. It's empty. Oh yeah, okay, you can return itself because it's empty. That makes sense. Otherwise, lazy sequence. I mean, you can put lazy sequence at the top here. Drop one. FF of F. Yeah, that's effectively what I did. When H. Cons F of H. Otherwise, I don't think you return anything. I think you just return nil or something. I like the if. The if makes it straightforward. The when is a little less clear what to do. What happens. Yeah. Win at tic-tac-toe. As in problem 73, a tic-tac-toe board is represented by a two-dimensional vector. X is represented by X, O is represented by O, and empty is represented by E. Create a function that accepts a game piece and a board as arguments, and returns a set, possibly empty, of all valid board placements of the game piece, which would result in an immediate win. Board coordinates should be as in calls to get in. For example, 0, 1 is the topmost row, center position. So there's a game piece, a board state, and then you're given a sequence, and then you're gonna return a sequence of possible moves that will win the game. Aha. So first things first. There's a pretty neat algorithm or function that was written in problem 73, which basically determines whether or not a board state is a winning board state. It'll tell you who won that particular board state. And what we can do here is actually great. We can say iterate all of the over all the possible board states, and then figure out who won, and then of the ones that won, for each of them, figure out which ones won with the piece that you're looking, filter over the piece that you're looking for, with the ones that, if any of them, yeah, figure out who won for each of these states, right? And then I guess you could filter on when the winning piece is X. Actually, that's it. Yeah, it's that simple. You could just filter over and dump that into a set. So using problems part 73, we can make this really easy. Now let's see if I can remember part 73. Write it up quickly. It's pretty. There is a really neat solution for 73 that I really liked. Let's see if I've got it kind of memorized by now. Boom, boom. We got 5 different cases here. Boom, boom. 1, 2, 3, 4, and 5. Alright, for each of these, we're going to go ahead and add an extra one of these guys, whatever you call it, a parentheses. Call this a win. Tic-tac-toe. We're given piece and board. I'll just tell you right now, we're going to use a series of functions. And let's go ahead and replace. Okay, ready. Now, first things first, we want to just take this first test case and we're going to write a routine which figures out who won. Alright. No, let's just do it this way. Okay. So a winner be this function, which takes a board state and returns a winner. We'll explain how that works shortly. What we want to do is just print line. Oh, well, it's okay. Excuse me. Alright, so we take this board state. Now, this is a very interesting kind of idea. We're going to use a let, of course, and we're going to define a few things inside here. So what we want to do is we want to get the diagonal, so forward diagonal. That is going to be how did he do it? He did, yeah, it's a zip, right? Zip map, or just zip. How do you do that when you zip Clojure? Zipper. I don't know what this does. I don't understand at all. A zipper. I don't know what that means. What the heck is a zipper? What does it mean? Functional hierarchical zipper with navigation, editing, and enumeration. See Hewitt. Hewitt? See Hewitt? What? I don't understand. I guess this is like a tree structure. Okay, that's interesting. This is like, it makes me think of like a what do you call that? A tree that has, it's like an iterator. It's like a tree that has threads. It's like a threaded tree. Don't know how I got there, but look at all them jobs. Look at all them jobs. Yeah, I could just map vector. That works too, map list. Forgot about that. So this is like a tree sequence kind of thing, the zipper. Very interesting. Anyway, yeah, about that. So we just want to map list of, now this is kind of interesting. I want to say like aget of 1, 2, and this is a range of, so we'll just go ahead and say number of rows is count of board, number of columns is if board is empty, zero, otherwise count of first of the board, right? So aget number of rows. This really is just count a board. We're gonna go and assume it's square. Let's call it n. So you've got range n, right? Now what's going to happen here is you aget over the board, and then you do this twice. But what's neat is you can go the other diagonal and say backward diagonal and reverse one of these. Yeah, just reverse. Doesn't really matter where you put it, as it turns out. And what this will do is it'll go, this is actually the other way around. This is the backward diagonal. So the forward diagonal is actually, it'll be like 3, 0, 2, 1, 1, or rather 2, 0, 1, 1, 0, 2, right? And the forward diagonal will be, yeah, and the backward diagonal will be the other way around. It's the 0, 0, 1, 1, 2, 2. Pretty cool. So you get this forward diagonal, backward diagonal, right? Then you say columns is going to be map list of board, right? And then now you say all, just concatenate the columns with the board, which is the rows, and then dump backward diagonal and then forward diagonal into a set that you're going to concatenate with, right? So you get everything, all the different possibilities, and then you say I thought this was pretty cool. So you start with all, and you say, okay, we're going to map set to each of these, right? Then we're going to say filter on the count of these being equal to 1. Right? So they're all the same value, whatever that value is. Filter on the sets, right? And then we say sum of, this is actually going to be a set, either there's only X's or O's are the only pieces that we care about, right? If it's otherwise return nil. So what'll happen is if any of what's left over matches X or O, that depending on which one matches first, then you've got a winner. Now the thing about this is actually we probably want to know yeah, this is a tricky thing because technically you could have a draw kind of a thing going on, or both of these match, but you just want the first one that matches. We're going to assume the input is sort of formatted nicely where we don't have, I guess, contradictions, like where there's already 2 winners or there's already a winner and then we're being asked to put a piece in somewhere to declare another winner, something like that. Like we'll just assume it's not badly formatted, this board state. And this will return nil if neither of those are present. And that's it. That should do it. So the winner should be nobody initially. So yeah, I memorized how to do that, but that was a really clever approach first time around, and still clever. Matching a get found taking 2 args. You're kidding. Is this not variadic? Is this not a variadic? A get array indexes. Yeah. I don't know. There's another one of these, which is it's not a get, but it's nth. No, it's like a special get. Get in, that's the one. Yeah, get in with keys. I don't know why a get didn't work. I guess it just doesn't. I mean, okay. Not that big of a deal. Let's give that a shot. False, 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 false. Object. Doesn't sum return whichever of these it is? Could do another one of these. I like this log, man. This is good. This is useful when you're trying to debugger. You're trying to debug these threading macros. All right, so whoa. Let's take it from the top. This doesn't quite look right. I'm really confused, so I'm just gonna go ahead and do this. Oh, okay. Yeah, I don't think this matters. Okay. What we get is all of these. Okay. Then, no, each of these should be made into a set. Uh-huh. Oh, some of these are sequences with one element in them. Oh, that's kind of interesting. Huh. Why, really? Oh, because the board is, right. No, oh, what? Hold on, what? List over board. What is? What happened? I think this is towards the top. We print. Yes. Oh, wow. The columns are sequences. Oh, huh. Oh, yeah, that's why. Duh. I didn't really think that through. That's my mistake. Done goofed. There we go. That's what we're supposed to do. We're supposed to use apply map list or just map v. Doesn't really need to be. Doesn't really matter how you do this. Why? This all could be map v just for the sake of it. Doesn't really make a difference. That should be a little bit better for, oh, okay. What? Excuse me. What? What happened? Doesn't... Huh? Whatever, it's fine. Doesn't make a difference. It doesn't make a difference. I thought map V was... Actually, now I'm just confused. It shouldn't matter. It really shouldn't matter at all. But maybe it does, I don't know. Okay, so yes. Take this set of things. There we go. Nobody wins. Okay. Good. Okay, that's what we wanted. Alright, let's get back to... Now, what was the error that I made there? Or had these problems? I didn't apply the map to the sequence. So this was the sequence of things. This map list, all it does is just takes the whole thing and makes it one giant sequence, as if you called list on one element, which is kind of silly. So you got to apply and make these into multiple collections that we're mapping over. And that'll give you the columns. Yeah, there we go. Okay, so we got a routine to get the winner. Now all we've got to do is say winning positions, and that function is going to take the board, piece board, and say list comprehension for we have row range of n, column range of n, and you've got all of these row column, right, these, and you say actually return a few different things. It's going to be a sequence of associate board at, oh, this is going to be tricky. Can we do update in? Update in board with RC with the piece. Alright, and now we're going to say map winner over these sets, over each of these, and then no, it's not even map, it's just plain old filter. Make a set out of that, and we're done. Sure, winning positions, piece board. Don't really need to make that its own function, do we? And let's see how we do. Let's see how we do. So, and in this context, Ah. Take it back. Oh no, wait. No. Oh. Oh. Could use that in both of these cases. Oh, for the longest time. Oh. So we don't have faulty inputs either. Whoa, for the longest time. Whoa. See what we get. See what we end up with. Empty set. Nice. 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 Whoa, for the longest time. Whoa. Yeah. Never mind, I don't know. I don't know what this gives us. I get the feeling it's not what I was thinking. Nil E. Oh. I mean, yeah. What? Wait a minute, what? Excuse me. Why is this nil? What? Are you kidding me? Right. Oh, please, come on. Map keys function arguments. Okay. Map keys, and then F just returns identity. Whoa, for the longest time. Whoa, for the longest time. Constantly. Is that what we're doing here? Okay. So that's good. We get this X here, X, E. Now, another thing to note here is it really should be if, yeah, can do it this way. We want for the longest time. Whoa, for the longest time. Whoa. It's actually the other way around. We say if. So we need a proper function for this. We say if what's there is equal to empty. It's only the ones that are empty, and then we'll return piece. Otherwise, we return what's there. Alright, that's So I want to update, and then we want to take the set over those things. And then we filter on, maybe we can do one of these guys. Jeez, man. Make a set out of those, and then filter on winner. And make the results of that in a set as well. Let's see what we do. Maybe not a filer, but a filter. A filer, let's say no, not a filer, but a filter. Okay, nice. Nice. This is not what I was going for. Okay. Yeah. What? Whoa, for the longest time. Whoa. That's one. That's two. Put the X in the second spot. This one, put the X in the third spot. Right, so only works for, okay, yeah, that makes sense. Only works for the spots that have the E's where you're looking, right? And then what we want to do is filter on winner. Whoa, for the longest time. Whoa. None of those are winners. Oh, yeah, that makes sense. Because you don't want the winner. You want when the winner is equal to. You also want not the update in, but you want something a little bit different here. You want you kind of want this. I'll show you what I mean. You want row column such that when you filter on winner of this is equal to, yeah, when the winner of this is equal to the piece. That, I think, is what we want. Oh, it's confusing as heck, but got it. I think I'll go ahead and turn this into a function as well. Nested, not allowed. Oh, nice. Can just use like function. Whoa, for the longest time. Oh, still empty. You gotta be kidding me. You gotta be kidding me. No. No. few things to consider here. For starters, holy smokes, man. So okay, so we can use this list comprehension. That's fine. We can update the board if it's empty. Update it with the piece. Otherwise, oh, yeah, whatever value that is. Right. We get that value. Apply a function to it. Say if that thing is empty, then we set it to piece. Otherwise, yeah, that's all well and good. That gives us a new board. We get the winner of that board. Right, figure that one out. And then we say if the piece is equal to that the winner, then you know what I want to do? I actually want to map this function. I don't want to filter, I want to map. Woo, this is like a really, logically, this is like super simple. False, all across the board. What do we end up with though? That's kind of confusing. Woo, for the longest time. Woo. Really, none of these win? 2-2 should win, right? Yeah, how do we not? Do we not get 2-2 anywhere? Don't apply winner, just update. What does this look like? Do we not get the case? Do we not get what we're looking for here? Yeah, it's right here. This should win, no? Whoa, for the longest time. Whoa. Oh, you gotta be kidding me. Serious? What? What? Is that a joke? Thought we had the right idea, man. I guess we didn't. You've got to be kidding me. Also, where are all these print statements coming from? Let's hold off on a minute here. Hold on a dang old minute. Whoa, for the longest time. Whoa. Alright. Oh. Not sure if that really matters. Just go. No. This gives me no. You've got to be joking me. No. No, 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 no. No, 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 no. Come on. Didn't we not just... What did we do wrong here? What the heck happened? I thought we had this. I thought we did it correctly. Maybe we just need to flatten this. Maybe that's the issue. So maybe yeah, okay. What? That's extremely confusing. What's going on? There we go. That's what I wanted. Alright, you know, because there's so many opportunities to mess up the sequences. Because right, this filter ends up with a sequence of sets that have one in them, which is not the same thing as a sequence of single values, which is why the sum doesn't work unless you concatenate these things. Got it. Okay, that took a while, but I think we got to where we wanted to be. So what happens if we do this? Woo, for the longest time. Woo. Right. Okay. So now if we put winner in here, right? Let's see what happens now. Nice. Oh wow. A lot of winners. Constantly winners. All these are winners. Interesting. Okay. Oh, for the longest time. Whoa. Alright. That's what we wanted. Filter on this being equal to piece. And then yeah, that's fine. And then making a set out of that. And you should be done. Okay, that took a while there. Took a while there. Really simple in theory, a little more complicated in practice. Yeah, should not have taken that much time. I mean, I had the idea very quickly what to do, but got kind of hung up on some things here. Yeah, the thing we really got hung up on was this part, and also this part. Yeah, using apply correctly. I guess that'll come with experience over time. But just remember to use apply correctly when we're dealing with like, multiple sets. But yeah, this is super efficient, like super concise. Really like this approach. And then you could just pop everything together, squish everything together, get a very like this really should have taken us like 10-15 minutes, but it took me a lot longer because I done goofed. Whoa, for the longest time. Whoa. Wow. Yeah. Got freaking deja vu all over again because all these solutions have I've seen this problem so many times in the past. There was a period of time where we were just constantly going over like writing a tic-tac-toe program because that was one of the triple byte questions, something about tic-tac-toe. Whoa, for the longest time. Whoa. Actually, this question might be easier than checking if there's a winner because you're possibly adding a value to check if there's a winner. Like, how do they do this? No, this guy writes a winner routine. Never mind. Winner sum concatenate B with apply map list B, right, and then you want list of 0, 1, 2, 2 minus map. Okay, so this is effectively what I did. This part, just sort of in one fell swoop. Oh, that's interesting. Huh. I think if you get this, then it returns. Oh, so this is actually a map, not a hash set. Oh, that's kind of interesting. Oh, so you apply. Oh, that's kind of clever. It's a little bit better than doing all this extra work here. All this stuff. Neat. Could do this even more concisely. And right, this returns, it looks like a oh, I see. Yeah, so he just applied this twice. So sort of just get. Interesting over these three. Yeah, I zipped over the range. You don't need to do a zip though. You can do a sort of double vector. You could actually do like a get in. over this range, then just apply a subtraction, right? Interesting. You could have gotten rid of these, and then this would just be once, twice, one, twice, and then this is n minus this value here. Yeah, you could have done it that way as well. Neat. Okay, and then he did a similar thing to what I did, which was associate in, update in, associate in. Yeah, associate in would have been better. Had two when clauses over this. Oh, that's interesting. Yeah, so he used his filters here instead of filtering explicitly this way. You could have used when clauses inside the list comprehension. Just when the thing is E. When the value there, so you just yx double get. You can do a get in as well. I prefer get in. Row column yx. So you just when get in is equal to E at that location, and when the winner of is equal to P, the piece, when you do associate in. So you don't need to use update in. Associate in doesn't use a function. Associate in, yeah, okay. And then that kind of simplifies things a bit. I like this solution. This is almost the same as mine. It's just that his is a little more concise. A little more concise. It's pretty good. I like that. I like that. All right, what else we got here? Sum of square digits. Okay, we'll keep going. Write a function which takes a collection of integers as an argument. Return the count of how many elements are smaller than the sum of their squared component digits. For example, 10 is larger than 1 squared plus 0 squared, whereas 15 is smaller than 1 squared plus 5 squared. Takes a collection of integers as an argument. Return the count of how many elements are smaller than the sum of their squared component digits. What? How many elements are smaller than the sum of their squared component digits? There's definitely a certain bound on this number. Like if you have all 9s all the way across, there's a certain point where 9 squared times, I don't know, say 5 is already less than 1, 2, 3, 4, 5. Yeah, it's always actually 9 squared times 4, 9 squared times 3. This happens pretty quick. Alright, it's only like the first 100 numbers that have this property. After that, just forget it. It's only 50 numbers within the 100 range. After that, it's all the same. It's interesting. You can actually make you can make this calculation really simple by just if you're greater than 100, it's just 50. Otherwise, you can just count it directly. Loop over each number and count. It's kind of fun. Let's see, how do we do here? If you're greater than or equal to 100, just do 50. So let's get rid of all this. All right, so we'll call it okay, square digits, square sum, squared digits, or just F. I don't call it F. Who knows? Call this thing. All right, what I want is let digits be this function. Now you've written this function multiple times now. We can say digits helper, or yeah, it's helper. Never mind, do it this way. This will have a let in there too. And it's going to be if 0 of x, return 1. Otherwise, we've got math log 10, math floor, int increment. And then what we're going to do is say reduce or iterate over the quotient of x. And we're going to take n. One digit would be 1, 2 digits 2, right? And we want to map modulo 10. That'll give you your digits from smallest to largest. And now we want to say digits square sum of x is going to be apply plus over, and we'll do it this way, apply plus it's going to be digits of x to square, which is like just right, square those digits and add them all together. Really, it's going to be a map, right? And then add those together. Square sum, and we do something real simple, such as take this range up to, now we say if x is greater than 100, return 50. Otherwise, we're going to say map this function over the range of increment x, and we're going to say digits square sum of x, and we want to say this digit square sum of x is greater than itself. And what are they saying? Elements are smaller than the sum. Yeah. So you want to be smaller than the digit square sum, right? It's either true or false, and we actually want to say, how do you do this? Even just filter and count. Range, filter, finally count. Okay, it seemed a lot simpler before. This seems simpler in my mind. Actually, programming it seems to be taking 0 arguments. It was a lot simpler in my mind. We actually got down to programming it. Took a little longer. Oh. Come on, man. Range cannot be cast to a number. Oh. It's actually just X that goes in here. Interesting. Oh. Never mind. Guess I don't have a choice because this is an arbitrary sequence, not necessarily a this is an arbitrary sequence, not necessarily a actually we can do this. That's fine. I don't think it matters. I was gonna say if we were only given a a single number that defines like what the range is going to be that we're looking at. This is a little bit easier, but it's actually an arbitrary sequence that we're given, so not necessarily can't necessarily take advantage of the fact that numbers larger than 100 will always be false for this property. We still may need to check all of that. We could maybe intersect our sequence. That may not be a bad idea. Just first filter on the whatever we were given, filter on only the values that are less than 100, and then operate. I could do it. That's not a bad idea. And this is sort of always constant time. You could say take the first 100 values of the sequence, right? If it's a lazy sequence, and then, well, no, it could be infinite. If it's an infinite sequence, you could end up with an infinite number of these things, right? Because it could just be like the same value over and over again, and so it's true. So you actually end up returning an infinite sequence. So you're kind of better off with this filter. The count of the filters could be infinite. Kind of curious what happens if you do this on a range, on something like I wonder what happens if you do this. Oh, interesting. So it does not handle that case particularly well. That's neat. And then it also would not handle the repeating case well either. It would need to return infinite. Even though I can tell you that I know it'll be infinite, the program's not smart enough to figure that out. Which means that humans think a little bit differently than machines, don't they? Somehow I know that iterating over and over for, like if they're asking for how to count the number of elements from the set, for which this says satisfied. If it's an infinite set and it's the same value over and over again, then you're just counting, right? You're counting to infinity. Every element satisfies. Even, you know, things that have sort of like infinite subsequences, but all those values satisfy, you still end up with infinity. These things are clear to a human, clear to me, but how could you let a machine know that? How could the machine determine ahead of time whether or not it's going to be an infinite thing that's trying to count? It would need a little more faculty, a little more advanced faculty, I think. It would not be such a simple program, I suppose. Basically, I imagine there are certain instances that are or are not so obvious. If you can remember them, sort of an algorithm to determine whether or not the thing you're looking at is going to be an infinite sequence. Then you can apply each of those different heuristics, I guess. Your heuristics probably operate a lot like a Bloom filter, where you could tell if it's definitely there or not. You can tell, what is it? How does a Bloom filter work? It tells you if it's not there. It'll tell you with certainty. But if it is there, it'll be some probability that it's there. Yeah, Bloom filters are interesting. not necessarily be there. Yeah, interesting thing about bloom filters, they basically tell you, for very large amounts of data, it'll tell you certainly that this element is not in the set for all those elements, which is a lot of possible huge set of elements. But if it is in there, it'll just give you some probability that's there or not, and then you've got to check directly whether or not it's there. Allows you to handle caching very well as a use case. I don't know whether or not the pieces of data are cached, which is an interesting question when you're dealing with like web browsers and like not just web browsers, but like the World Wide Web, we'll say. Vaguely speaking, the World Wide Web. Oh man, why am I so itchy? Yeah, also I got this, my head is super itchy. It's got, I think there's I use this soap that's like it's supposed to help with your itchy scalp, but I haven't taken a shower in a few days because I stopped exercising this week because I wanted to work on these problems. And so I didn't shower because I would usually shower after exercise, and then I didn't use the soap. It's good soap. But yeah, definitely an interesting question that this cannot easily tell whether or not it's about to return an infinite sequence. It's kind of neat. It's kind of neat. Anyway, we can move on to the next question. Nice. And these folks really squish these together. Oh, I see. Yeah, they're even more concise because they used to get the digits. They used string, then to sequence, then to the digit from that character. Subtracting 48 looks like, which I guess is the value of digit 0, or the character with the ASCII value is. Yeah, then and there's these two maps here. This is kind of weird. There's this double mapping going on here. I don't fully understand that. I do not fully understand that. I guess because you're operating over every element of the collection. So you gotta map everything. Kind of interesting. Neat. Neat. Filter true greater than. It's kind of funny. Alright, moving on. Moving on. Okay, so that's problem 120. And it's a universal computation engine. Okay. Medium. Eval, resolve, special restrictions. So Clojure has an eval as well, and Clojure also has a resolve. Okay. Resolve symbol same as ns resolve ns symbol or ns resolve ns environment symbol. Resolve symbol resolve environment symbol. User first symbol resolve 1, 2, 3, 1. Resolve nil defx 1 resolve join Clojure string join AB resolve join. What does this do? Resolve symbol resolve environment symbol. Same as ns resolve ns symbol or ns resolve ns environment symbol. Okay, that doesn't really explain so much to okay. User first symbol resolve. Oh, so itchy. Oh, it feels so good. Resolve 1, 2, 3. So symbol first, resolve that symbol. 1, 2, 3, 1. Huh. Namespaces. So I guess this does something to the namespace. Resolve X. Resolve join. Nil. Use string only join. Resolve join. Oh, okay. Got it. Alright, seems to let us know where it is in the namespace. Fair enough. Fair enough. Excuse me. Oh, okay, so you can use resolve to get a function from the namespace. Very interesting. Anyway. And then eval, what does that do? Evaluates the form data structure, not text, and returns the result. Okay, def foo, print this thing. Okay, foo, string, eval foo, notice evaluating the string does not work. Eval read string. So if you read the string from foo, that gives you a form, and you can evaluate that form. So print 1, 2, 3, evaluate this form, let A10, add 3, 4, and 10, 17. Interesting. So you can evaluate the form. Not the text though. It's a form data structure. It's different from text. It's kind of interesting. Read string. Reads one object from the string, optionally include reader options specified in the read. Execute code, and as such should be used only with trusted sources for data structure interop use. Read string. Okay. Interesting. Interesting. Oh, didn't mean to do that. So no eval, no result. I kind of want to go to bed. That's what I'm getting at here. By the way, I'm going kind of slowly because I'm just. We have 35 problems left. All right, slowly getting there. I'm gonna get going. I think I'm kind of tired. I'm like really tired, and got a pretty good amount of time in here. Cutting it about 10 minutes early. Given a mathematical formula, so they don't want us to use eval or resolve. I'm not entirely sure what these will do for us. I think I would need to manipulate these use these a little bit more to really know why we would not want to use those, or why they would not. Yeah, why we would not have those available. I imagine it has something to do with like evaluating forms, and I guess resolve would pseudo evaluate the function, probably something like that. Anyway, so given a mathematical formula and prefix notation, return a function that calculates the value of the formula. The formula can contain nested calculations using the 4 basic mathematical operators, numeric constants, symbols representing variables. The returned function has to accept a single parameter containing the map of variable names to their values. Interesting. So okay. So this is like functions. All right. So we're gonna return a function that calculates the value of the formula. Okay. Oh, this is really cool. So you're given some form, right? And then what you've got to do is return a function that, when given a map of the parameters, will evaluate your expression. Let's say it's an expression. So we're given an expression with variables in it that only uses mathematical operators, and numeric constants and symbols representing variables, right? And we're going to, given that expression, return a function that'll accept a mapping of the variables, and then it will evaluate the expression. Yeah, very interesting question. Don't really have any ideas immediately. And this is only using prefix notation. So you can do this recursively, I suppose. Yeah, I guess it's not too hard. You can do it recursively and say, you know, there's a symbol, and then there's an operator, and then there's 2 subtrees to evaluate, right? And so you recursively evaluate those 2 expressions, and then use the mapping depending on which operator you're looking at. Then you can easily just apply, right? There's only 4 different operators to consider, so you can use a simple switch statement, and then you just have, when you are dealing with base cases, if the expression, so all the way at the base we have if the expression is a variable, then you simply replace the variable use your map to replace the variable. If it's a constant, just return the constant. And yeah, you really only have 2 options to consider, otherwise it's badly formed. It's either an expression with 3 pieces, an operator, another expression, or it's just an expression like either a constant or a variable, right? So you only got a few different cases. So it's actually relatively easy to evaluate if you're doing everything in prefix notation, which is pretty cool. It's pretty neat. I think that's one upshot to Clojure, is that it's like super simple in some sense. Super simple to sort of parse and build programs using. I really like it, man. I like this Lisp style functional programming. It's super fast. Once the program is already up and running, it's extremely highly optimized because it's got a Java compiler in there. Yeah, I like Clojure. It's pretty cool. It's pretty neat. Pretty neat. Can't wait to start doing stuff with it. Start messing around with Clojure script and like other programs I can to tinker with, toy with. Oh, there's a lot of goodies we can get our hands on. We can start tinkering with. There are lots of goodies. Yeah, there's a lot of fun stuff. There's a lot of things I'd like to get into once we get through these questions. I don't know what I want to look at first. I kind of want to look at trading algorithms, because I've been doing some trading on my own involving like just, when I see a stock is up, I sell. When I see it's down, I buy. I've just kind of been doing that over and over. But it's, I did really well at one point, but then I got kind of like antsy and switched directions and lost a lot of money, and like kind of did sort of like not what I initially planned on doing. What I initially planned on doing made me like $2,500 in a very short period of time. I want to say like a couple weeks I made it, $2,500. But then after I sort of lost my what do they call that? Lost faith in my initial strategy because I lost a little bit of money, and then I lost faith. And if I held, I would have been fine, but I didn't hold and lost a bunch, lost a lot. Yeah, so now I'm kind of like in this weird, like, what do I do? But if I write a program to trade and it let that sort of happen automatically, automate my trading, then I think I'll make a lot of money, and I won't have to actually do anything. It'll just kind of operate on its own, which I would like that. That'd be nice, because there's like opportunities that I keep missing, just because I'm like kind of greedy. I see it where it's like, okay, I can make a profit. Like, instead of just taking the profit, I wait for it to go higher, the greater profit, and then it actually goes in the other direction because it's so ridiculously volatile. And I'm like, right, instead of making $20, lose $60. It's like, and if I was trading with more money, it'd be multiplied, right? Like, before I was trading with a lot more money, and it would have been like make $100, lose $300. It's kind of the deal. Yeah, if I just automate all this, I'll just make pretty good money all the time. I just keep pumping money in and don't even worry about it. Don't even think about it. Make that 70% returns a year. I like that. I like making 70% of my wealth every year. It's good. some quality returns, quality gains. Anyway, let me get going. Yeah, this shouldn't be too bad. I guess they gave it medium, which is fair. So yeah, thank you all for watching. Hope you had enjoyed yourself. And that actually is my time anyway, so that's kind of good. At least we hit the mark. Yeah, have a nice day. Thanks for watching. Talk to you soon. And oh, what happened? Oh, you're kidding. When did that happen? Oh my goodness, not again. This kind of like just periodically happens where I just lose the screen. How long ago was that? When did that happen? Oh boy. What is going on? Why did that happen? What happened? Last like 5 minutes of the stream were just blank. Is that because of hold on. What the heck happened? Oh wow. Jeez. That was because I tried to use an infinite sequence, or I called the map. Oh no, it just cut out for no obvious reason. Dude, that's kind of weird. I don't know why that is. Well, I'm gonna get going anyway. I'm sorry. Oh wow. All right, we'll review that. We'll come back to the question that I looked at here. Dude, what the heck? Oh, you guys didn't even see that one? Oh no, you missed all of this. What is even going on? How much of this was just black? Oh no, is this just off or? Oh wow. I need to re-upload this. Oh no. I think I'll have to review this. Oh man, that's terrible. What happened? What? Alright. I'm just gonna end stream there. I'm sorry. This is sad. I'm sorry. I don't know what happened. Oh. Oh. What the heck? Technical difficulties. Yeah. I don't know at what point my OBS just stopped. I should be checking it periodically for that. I don't know why that's so weird. That is so strange. Anyway, who knows what happened there? It just suddenly stopped showing the screen. So anyway, thank you all for watching. Talk to you soon. Have a good rest of your day. I guess tomorrow we'll just like review a few of the previous questions, how I did it. Oh my goodness. Wow, that sucks. That sucks real bad. Wow. Wow, 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 wow. I'll just restart from where it was. Oh my goodness. I'm sorry. Well, take care.